Welcome to Brain Vision.
So we have a uniform cube with a length of, it's a 75 kg, so we're going to say m of cube is 75 kgs, and we have a rod with a mass of 70 kgs, and we're told that a couple m is applied to this system while from rest, and that the r of the cylinder or the rod is 4 inches. Hold on, I'm looking at the wrong problem. I apologize for that. So the M, we got weight here. So the weight of this cube is 144 pounds. And the weight of the rod is 136 pounds. The radius of the rod is 4 inches, and the length of the cube is 12 inches. We have a time interval of 4 seconds and a final angular momentum of 960 RPM. So if we multiply this by 2 pi over 60, this will give us the conversion to radians per second. So this is 100.5 radians per second. And we're being asked to find out what is the value of the couple m. So we know we want to convert this into mass. So we have to divide this by 32.2. Feet per second squared. And this is pounds. So then we are going to get 4.47 pound second squared over feet. And we're going to do the same thing for this guy, and we're going to get 4.22 pound second squared over feet. So now what we have to do is we have to find out what are the moments of inertia of the cube and of the rod. So the ICs is going to be 1/12 m of the cube times L squared plus L squared. So that's going to be 1/12 times 4.47 times 2 times 12 squared. This gives us an IC of 107.28. And what are the units of this? Good gracious. It's going to be pound second squared times feet. So we're going to do the same thing with the rod, except this time we have 1/2 mr squared for our moment of inertia. That's 1/2 times 4.47, no, 4.22 times 4 squared. That gives us 33.76 pound times second squared times feet. Except I've made a mistake here because this is in inches. So this is 1, and 4 inches is 1/3 of a foot. So this is 0.33. That's 1. So let's get rid of these guys right here. So 2 times 4.47 divided by 12 is 0.745 pounds times seconds times feet. It says second squared. And down here we have 0.696 pounds times second squared times feet. So now we are going to combine these together to get I total. It's going to be IR plus IC, which is going to be 1.44 pounds times second squared times feet. Now we can use the conservation of angular momentum to solve for our m. So m times t is going to be equal to I omega. So m is going to be equal to I times omega over t. So that's 1.44 times omega, which is 100.5 over 4. So that gives us 36.18 pound feet. So if we want to find that in inches, just to multiply by 12 and we get 434.16 pound inches. Did I make a mistake? The answer is yes, because I was supposed to square this 0.33, which means that this number is wrong. This number is wrong. This number is wrong. And these numbers are wrong. So we have 0.33 squared times 4.22 divided by 2, 0.222, let's say 230. That plus 0.745 is going to give us 0.975. So this is 0.975. So that times 100.5 is divided by 4 is 24.49 pound feet. And it's the same thing as 200 94 pound-inches. And there you go.